Now please turn to page 23 of Chapter 34. Let's talk about the determination of enthalpy change of formation. Underline, direct determination of enthalpy changes of formation by simple colorimetric methods is difficult in most cases. Direct determination of enthalpy changes of formation by colorimetric method is difficult in most cases. This is because some formation reactions are highly exothermic, cannot be safely carried out. On the other hand, the constituent elements are in different physical states and cannot be mixed well in a colorimeter. Now I think the third one is the most important. Side reactions may lead to the formation of side products. Side reactions may lead to the formations of side products. Now first of all, what is the meaning of direct determination? Let's have a revision. Turn back to page 18. It is about the enthalpy change of neutralization. We can determine the enthalpy change of neutralization directly by using simple colorimetric method. That means by using coffee cup. Do you remember? Here you have a polystyrene cup and then put it into a beaker with cotton wool so that it can reduce heat loss to the surrounding. Next, we have HCl. Measure its initial temperature. Next, mix NaOH into the beaker, into the polystyrene cup. Temperature rise. By using this equation, E equal to mc delta T, we can measure the heat released. Okay? Heat released. Similarly, turn to page 14. Page 14. In this page, we are talking about the determination of enthalpy change of combustion. Again, we can measure the enthalpy change of combustion directly by using this setup. Here we have a spirit lamp which contains the fuel, for example, ethanol. Here we light up the ethanol, heat is released and is transferred to the metal can and the water. Measure the temperature rise, then again use E equal to mc delta T to work out the amount of heat released. Next, we can calculate the enthalpy change of combustion. These are direct determination by simple colorimetric methods. However, direct determinations of enthalpy changes of formation by simple colorimetric methods is difficult in most cases. It's because side reactions may lead to the formations of side products. Now I would like to explain in detail by using this example. Standard enthalpy change of formations of calcium carbonate. First of all, please tell me what is the definitions of standard enthalpy change of formation of calcium carbonate. It's the enthalpy change when 1 mole of calcium carbonate is formed from its constituent elements in their stable physical state. Therefore, carbon, we need to write down graphite, O2 gas, balance this equation, put 3/2. It is the standard enthalpy change of formation of calcium carbonate. If we want to carry out the reaction directly, there are lots of side reaction. Lots of side reaction. What are they? Can you tell me? The first one, carbon will react with oxygen to form carbon dioxide instead of calcium carbonate. The second one, calcium will react with oxygen to form calcium oxide. Do you remember? Okay. That means if you are carrying out a direct measurement, that means you would like to mix calcium metal, carbon graphite with oxygen to form calcium carbonate, it is impossible because side reactions occurs. Carbon likes to react with oxygen to form carbon dioxide. Calcium likes to react with oxygen to form calcium oxide. In other words, if you mix these three reactants up, can calcium carbonate form? No. Calcium carbonate seldom formed, okay? Instead, carbon dioxide, side product, calcium oxide, which is also a side product, formed instead. So, how to determine the enthalpy change of formation? Standard enthalpy changes of formation has to be, underline, has to be determined indirectly by using another method. Underline, enthalpy changes of formation has to be determined indirectly by using another method. We are going to talk about this method in the next chapter.